Swayam Prabha. Digital India. Educated India.
Welcome to lecture 31st of the course on econometric methods for statisticians, data scientists and data engineers. The title of this lecture is General Form of Simultaneous Equations Model and the Identification Problem. In the last lecture, we have discussed some basic concepts of the simultaneous equations model. Actually, in many applications, in many economic applications particularly, we have a set of variables which are determined jointly by a set of equations. So, our model is consist of a set of equations instead of a single equation. Then in each equation on the right hand side as explanatory variable, we have some of the endogenous variables also. And since those endogenous variables are correlated with the disturbance term, if we directly apply the OLS procedure to estimate the parameters of each of the equation, then the OLS estimators are not consistent. Then with the help of an example, we have discussed three estimation procedures for estimating the parameters of the model. The instrumental variable estimation procedure, the indirect least square and two-stage least square. In this lecture, we are going to introduce the general form of simultaneous equations model. Then we will discuss the identification problem with the help of some examples. What are the issues related with the identification problem? When we say that a particular equation is identified or not. So, all these issues we will discuss in this lecture. Now, first we consider the general form of the simultaneous equation model. So, suppose our model contains capital M structural equations. So, the equations are beta 1 1 y 1 t plus 1 plus beta 1 m y m t plus gamma 1 1 x 1 t plus 1 plus gamma 1 k x k t equal to u 1 t. And so on. The last equation is beta m 1 y 1 t plus so on plus beta m m y m t plus gamma m 1 x 1 t plus so on plus gamma m k x k t equal to u m t, and then t takes values from 1 to n. So, in all you have n observations. So, each of these equations has some endogenous variables as well as some predetermined or exogenous variables. Then y 1 t, y 2 t, so on y m t, these are observations on endogenous variables. Then x 1 t, x 2 t, so on x k t are the observations on predetermined, that is exogenous and lagged endogenous variables. So, in all you have capital M endogenous variables and then you have capital M equations in the structural form of the model. Then beta I 1, beta I 2, so on beta I m and gamma I 1, gamma I 2, gamma I k, these are the regression coefficients. U I t is the disturbance term. Here I varies from 1 to m and t varies from 1 to n. Now, in this structural form, sum of the betas and gammas are 0. Otherwise, all the equations in the model look alike and no equation could be identified. Say if you look at all the equations, then you cannot distinguish between different equations unless some of the coefficients are equal to 0. So, we require certain conditions on betas and gammas to make these equations identifiable. Now, in matrix notations, we can write the model as, say, suppose we define matrix capital B as, say, beta 1 1, beta 1 2, beta 1 m and so on, beta m 1, beta m 2, beta m m. And then we define gamma as gamma 1 1, gamma 1 2, gamma 1 k and so on, gamma m 1, gamma m 2, so on, gamma m k. So, we define capital B and capital gamma like this. So, obviously, capital B is of order m cross m and gamma is of order m cross capital K. Then using matrix notations, we can write the model in the form, say, B y t plus gamma x t equal to u t, t equal to 1 to n. Then y t is equal to y 1 t, y 2 t, so on y m t. So, it is m cross 1 vector of observations on endogenous variables. X t is equal to x 1 t, x 2 t, so on x k t. So, this is k by 1 vector of tth observation on k predetermined variables. U t is u 1 t, u 2 t, so on u m t. So, obviously, u t is also of order m cross 1. So, this is the vector of disturbances. Then suppose B is non-singular, then your model is B y t plus gamma x t equal to u t, and you can write this model as y t equal to minus B inverse gamma x t plus B inverse u t. And then we write capital pi equal to minus B inverse gamma. So, in terms of pi, and then we also define V t equal to B inverse u t. So, in terms of pi and V t, we can write the model as y t equal to pi x t plus V t, t equal to 1 to n. Now, this is the reduced form of the model, because here in this form all the endogenous variables are towards the left hand side, and then each equation has just one endogenous variable. And then you have all the exogenous or predetermined variables towards the right hand side here. So, this is the reduced form of the model. So, structural form relations are the interaction between endogenous and predetermined variables taking place inside the model. Reduced form relations express the jointly dependent endogenous variables as linear combinations of predetermined variables. In each equation, you are expressing a particular endogenous variable as a linear combination of predetermined variables, whereas in a structural form, each equation is based on the interaction between endogenous and predetermined variables taking place inside the model. Now, we come to the identification problem. Whether the estimates of structural parameters of the model can be obtained from the estimates of the reduced form coefficients. So, you have structural form parameters in the matrices B and gamma, and then reduced form coefficients are there in the matrix pi. Using the reduced form, it is possible for you to estimate pi. Then, is it possible to obtain estimates of parameters contained in B and gamma using the relation between pi and B and gamma? Now, there are three possibilities. The first possibility is unique estimates of the structural parameters of a particular equation can be obtained. So, suppose we consider a particular equation, then it may be possible for you to obtain unique estimates of that particular equation. Then that particular equation is said to be exactly or fully or just identified. Notice that we focus on identification of each and every equation. It may happen that in the entire model, some of the equations are identified and some other equations are not identified. Then the second possibility is that more than one estimates of the structural parameters can be obtained. So, in this case, the equation is said to be over identified. You have more than one solutions, you have more than one estimates for the structural parameters. So, that is why the equation is said to be over identified. The third possibility is it is not possible to estimate the structural parameters by using the estimates of the reduced form coefficients. And in that case, the equation is said to be unidentified or under identified. So, now we explain the idea of identification or unidentified, exactly identified equations with the help of few examples. Now, first we consider the demand supply model. Here the demand function is q t d equal to alpha naught plus alpha 1 p t plus u 1 t, alpha 1 is less than 0, and the supply function is q t s equal to beta naught plus beta 1 p t plus u 2 t, beta 1 is greater than 0. So, the demand depends upon price and the supply also depends upon price, but as price increases, since we are taking alpha 1 less than 0, so we presume that as price increases the demand decreases. On the other hand, we are taking beta 1 greater than 0. So, as price increases, the supply increases, because the supplier gets more profit if the price increases. Then we have an equilibrium condition. The equilibrium occurs when the quantity demanded is equal to the quantity supplied, that is q t d is equal to q t s. So, QTD is the quantity demanded, QTS is the quantity supplied, T is the time, and then this PT is the price. Obviously, PT is also determined by this equilibrium condition, means corresponding to this equilibrium condition you get a particular demand and then you have a particular price also. So, both PT and the quantity QT are endogenous variables. Now, by equilibrium condition QTD is equal to QTS or alpha naught plus alpha 1 PT plus U 1 T is equal to beta naught plus beta 1 PT plus U 2 T. Now, to obtain the equilibrium price we solve this equation for PT. And this gives you the equilibrium price. So, if we solve this equation, then what we get? We get alpha 1 minus beta 1 P t, we take this term towards the left hand side equal to beta naught minus alpha naught plus U 2 t minus U 1 t, and then you can obtain the value of P t from here. So, ultimately you can write P t equal to pi naught plus V t, where pi naught is equal to beta naught minus alpha naught upon alpha 1 minus beta 1, and V t is equal to U 2 t minus U 1 t divided by alpha 1 minus beta 1. So, this is the equilibrium price, and if we substitute this equilibrium price in either demand function or supply function, then we get the equilibrium quantity. So, in any of these two equations you substitute the value of P t and then you get the equilibrium quantity. So, Q t is equal to pi 1 plus W t, where pi 1 is equal to alpha 1 beta naught minus alpha naught beta 1 upon alpha 1 minus beta 1. This you can easily verify, and W t is equal to alpha 1 U 2 t minus beta 1 U 1 t upon alpha 1 minus beta 1. So, you get these two equations. Now, these are the reduced form equations. In each of these equations, you have just one endogenous variable. The first equation, this equation 7 has the equilibrium price as the endogenous variable. The equation 8 has the quantity as endogenous variable. Then using 7 and 8, we can estimate pi naught and pi 1. You just apply the method of least squares. In fact, pi naught is simply P bar, the mean of P t's, and pi naught head, and pi 1 head is Q bar. So, we can estimate pi naught and pi 1. So, in fact, we have just two reduced form parameters, but in the original model you have 4 structural parameters alpha naught, beta naught, alpha 1, beta 1. So, to obtain these 4 structural parameters, you require at least 4 relationships, but you have just 2 estimates available to you, pi naught and pi 1, and between pi's and alphas you have just these 2 relations, pi naught equal to beta naught minus alpha naught upon alpha 1 minus beta 1, and pi 1 equal to this. Using these two relations, you cannot obtain solutions for alpha naught, beta naught and alpha 1, beta 1 in terms of pi naught and pi 1. So, in this sense we say that the equations are not identifiable. Now, we look at the identification problem from a different angle. So, suppose you multiply the demand function 4 by lambda and the supply function 5 by 1 minus lambda. So, you are multiplying this demand function by lambda and this supply function by 1 minus lambda, and then we add, then we get q t equal to gamma naught plus gamma 1 p t plus w t. What is gamma naught? Gamma naught is equal to lambda into alpha naught plus 1 minus lambda into beta naught. Similarly, gamma 1 is equal to lambda into alpha 1 plus 1 minus lambda into beta 1, and w t is equal to lambda into u 1 t plus 1 minus lambda into u 2 t. Now, if you look at the equations 4 and 5 and equation 9, then all the three equations look alike. So, equation 9 also involves the regression of q t and p t. Demand function and supply function also involve the regression of q t and p t. So, this equation 9 is observationally equivalent or indistinguishable from 4 and 5. Then what is the problem? Suppose you have a given data set on q t and p t and you are estimating the parameters using some method. Then we are unable to say which one of these models we are fitting, whether we are fitting the demand function or we are fitting the supply function or we are fitting equation 9, which is a linear combination of demand function and supply function, because all the three equations, the demand function, supply function and their linear combination look alike. All the three are observationally equivalent. You cannot distinguish between these three equations. So, in this sense, both the equations demand function and supply function are unidentified. You cannot identify these equations. Then we consider the example of just or exact identification. Now, suppose the demand function is q t d equal to alpha naught plus alpha 1 p t plus alpha 2 I t plus u 1 t. The supply function remains the same, is q t s equal to beta naught plus beta 1 p t plus u 2 t. Here I t is the income of a consumer. So, obviously, the quantity demanded also depends upon the income of the consumer, and usually as income increases, the demand increases. So, that is why we take alpha 2 greater than 0. Again, using the equilibrium condition q t d equal to q t s, we get the equilibrium price and equilibrium quantity. So, we take alpha naught plus alpha 1 p t plus alpha 2 I t plus u 1 t equal to beta naught plus beta 1 p t plus u 2 t. So, from here we obtain alpha 1 minus beta 1 p t equal to beta naught minus alpha naught plus, actually we have minus alpha 2 I t plus u 2 t minus u 1 t. Or we obtain p t equal to beta naught minus alpha naught upon alpha 1 minus beta 1, which is equal to pi naught. So, you have pi naught here minus alpha 2 upon alpha 1 minus beta 1 into I t. So, we are taking pi 1 equal to minus alpha 2 upon alpha 1 minus beta 1. So, you get plus pi 1 I t plus V t. V t is equal to u 2 t minus u 1 t upon alpha 1 minus beta 1. So, we get this equilibrium price, and then we substitute this equilibrium price in any of these two equations. Say we substitute this equilibrium price in equation 2, say, and then we get the quantity q t. So, you can easily solve it. Q t is equal to pi 2 plus pi 3 I t plus w t, where pi 2 is equal to alpha 1 beta naught minus alpha naught beta 1 divided by alpha 1 minus beta 1, pi 3 is equal to minus alpha 2 beta 1 upon alpha 1 minus beta 1, and w t is equal to alpha 1 u 2 t minus beta 1 u 1 t divided by alpha 1 minus beta 1. So, you get these reduced form equations. Now, you can obtain estimates of pi naught and pi 1 or estimates of pi 2 and pi 3 by applying least square procedure to equation 12 or equation 13. So, ultimately you have 4 reduced form parameters, but in the structural form you have 5 parameters alpha naught, alpha 1, alpha 2, beta naught, beta 1. So, still there is a problem, you have less number of equations than the number of unknowns, less number of relations between structural parameters and reduced form coefficients than the number of structural parameters. But still you can obtain the solutions for some of the parameters. Say if you divide pi 3 by pi 1, then pi 3 upon pi 1 is equal to beta 1. So, you can obtain beta 1 from here. So, we can obtain OLS estimates of pi naught, pi 1, pi 2, pi 3, but we cannot get the unique solutions for the 5 structural parameters. Then beta 1 is equal to pi 3 upon pi 1. This you can easily verify. This is pi 3, you divide it by pi 1, you get beta 1. And then beta naught is equal to pi 2 minus pi 3 upon pi 1 into pi naught. एक मिनट रोकिएगा. In fact, if you take pi 2 minus beta 1 pi naught, then you can easily verify that this is equal to beta naught. You simply take this expression for pi 2, multiply pi naught by beta 1 and then you subtract. So, you get beta naught and then you substitute beta 1 equal to pi 3 upon pi 1. So, beta naught is equal to pi 2 minus pi 3 upon pi 1 into pi naught. So, supply function can be identified. You can obtain solutions for the structural parameters of supply function. So, if you estimate pi naught, pi 1, pi 2, pi 3, then you can also estimate beta naught and beta 1, the structural parameters of the supply function. But the demand function remains unidentified. Still, you cannot estimate the parameters of the demand function. So, in this structural form or in this system of equations, one of the equation is identified, supply function is identified, but the other equation is still unidentified. And again we look at this identification problem from a different angle. So, we multiply 12 by lambda and 13 by 1 minus lambda and then we add. So, we get q t equal to gamma naught plus gamma 1 p t plus gamma 2 I t plus epsilon t, say, where gamma naught is equal to alpha naught lambda plus beta naught 1 minus lambda. Gamma 1 is equal to alpha 1 lambda plus beta 1 minus lambda, and then gamma 2 is equal to lambda into alpha 2, and epsilon t is equal to lambda into u 1 t plus 1 minus lambda into u 2 t. Now, you compare this equation with demand function as well as supply function. You will observe that you cannot distinguish this equation 14 from the demand function, but you can distinguish it from the supply function. This 14 is a linear combination of supply function and demand function. You can distinguish it from the supply function, because supply function does not have the variable I t, but this linear combination has I t, but still you cannot distinguish it from the demand function. That is why demand function is unidentified and supply function is identified. So, 14 is distinguishable from supply function, but indistinguishable from the demand function. Now, again we slightly modify the supply function. So, now your demand function is q t d is equal to alpha naught plus alpha 1 p t plus alpha 2 I t plus u 1 t, and supply function is q t s is equal to beta naught plus beta 1 p t plus beta 2 p t minus 1 plus u 2 t. P t minus 1 is price lagged one period. So, at time t, P t minus 1 is a predetermined variable. So, we presume that the supply not only depends upon the current price, it also depends upon the one period lagged price. Again, we can easily obtain the equilibrium price and demand. For obtaining the equilibrium price, what you have to do, just equate this demand function with supply function. So, we take alpha naught plus alpha 1 p t plus alpha 2 I t plus u 1 t equal to beta naught plus beta 1 p t plus beta 2 p t minus 1 plus u 2 t, and then you solve it for p t. Beta 1 p t towards the left hand side. So, you get alpha 1 minus beta 1 p t equal to beta naught minus alpha naught minus alpha 2 I t plus beta 2 p t minus 1 plus u 2 t minus u 1 t, and then we divide by alpha 1 minus beta 1. So, finally, obtain p t equal to pi naught plus pi 1 I t plus pi 2 p t minus 1 plus v t, and similarly, you can obtain the equilibrium quantity also. You just substitute this price in either demand equation or supply equation. So, you get q t equal to pi 3 plus pi 4 I t plus pi 5 p t minus 1 plus w t, where pi naught is equal to this. Then you have pi 1 here, pi 2 here, pi 3, pi 4, pi 5. And then let us see whether we can obtain the structural parameters by solving all these relations or not. In all, you have 6 reduced form coefficients, and then you have 6 structural parameters. So, there is a possibility that you get unique solutions. Say, if you divide pi 5 by pi 2, then you get alpha 1. If you divide pi 4 by pi 1, then you get beta 1, and so on. So, you can obtain all the structural parameters in terms of pi's. Again, we look at the linear combination of demand function and supply function. So, lambda q t d plus 1 minus lambda q t s is equal to lambda alpha naught plus alpha 1 p t plus alpha 2 I t plus u 1 t plus 1 minus lambda beta naught plus beta 1 p t plus beta 2 p t minus 1 plus u 2 t. And then you get this equal to gamma naught plus gamma 1 p t plus gamma 2 I t plus gamma 3 p t minus 1 plus epsilon t, where gamma naught is equal to lambda alpha naught plus 1 minus lambda beta naught. Gamma 1 is equal to lambda alpha 1 plus 1 minus lambda into beta 1. Then you have gamma 2 equal to lambda alpha 2, and gamma 3 is equal to 1 minus lambda beta 2, and epsilon t is equal to lambda u 1 t plus 1 minus lambda u 2 t. Then if you look at this equation is distinguishable from both the demand function 15 and the supply function 16. So, both the demand function and supply function are just identified. Say this equation has I t, p t minus 1 and p t involved in it. The demand function has p t and I t involved in it. So, you can distinguish it from the demand function. It has one extra predetermined variable p t minus 1. Then you can also distinguish it from the supply function, because supply function does not have I t in it. So, you can distinguish it from the supply function. Now, we consider the example of over identification. So, suppose your demand function is q t d equal to alpha naught plus alpha 1 p t plus alpha 2 I t plus alpha 3 r t plus u 1 t. And the supply function is q t s equal to beta naught plus beta 1 p t plus beta 2 p t minus 1 plus u 2 t. Here R t is the wealth of the consumer. So, we presume that the quantity demanded depends upon the price, the income and wealth of the consumer. Again we obtain the equilibrium price and quantity. To obtain the equilibrium price, again we equate these two equations and then we solve it for P t. So, we get this equation 22 and then we substitute this equilibrium price in any of these two equations and then we get the equilibrium quantity Q t. So, I am not going to give you the details of the derivation here. This is I am leaving as an exercise for you. You can easily verify it. Just equate these two equations, solve it for P t, you get this equation and then substitute the value of P t in any of these two equations, you get this 23, equation 23. So, these are the reduced form equations. And then using these reduced form equations, you can estimate pi naught, pi 1, pi 2, pi 3, pi 4, pi 5, pi 6 and pi 7. Now, you have 8 reduced form parameters pi naught, pi 1, pi 2, pi 3, pi 4, pi 5, pi 6, pi 7. But you have 7 structural parameters. So, you have more equations or more relations than unknowns. Pi naught is equal to beta naught minus alpha naught upon alpha 1 minus beta 1. Similarly, pi 1 is equal to minus alpha 2 upon alpha 1 minus beta 1, pi 2 is minus alpha 3 upon alpha 1 minus beta 1 and then you have these expressions for pi 3, pi 4, pi 5, pi 6 and pi 7. Then V t is equal to u 2 t minus u 1 t upon alpha 1 minus beta 1 and W t is equal to alpha 1 u 2 t minus beta 1 u 1 t upon alpha 1 minus beta 1. So, demand and supply function have 7 structural parameters and then there are 8 reduced form coefficients to estimate them. So, unique solutions for all the structural parameters are not possible and you may have more than one solutions. So, for example, you take this pi 6. If you divide pi 6 by pi 2, then you obtain beta 1. Again, you take pi 5 and pi 1. If you divide pi 5 by pi 1, then again you obtain beta 1. So, on the basis of estimates of reduced form coefficients, suppose you want to estimate the structural parameters, then you have more than one estimates for beta 1. So, this is the problem of over identification. Although both the equations are identifiable, and if you take linear combination of both the equations, then you can distinguish that linear combination from demand function as well as the supply function. But here this is the case of over identification. Say you have more than one solutions for beta 1. So, this equation is over identified. So, in under or unidentified case, the estimation of parameters is not at all possible. In this case, you do not have enough estimates available for structural parameters. So, on the basis of reduced form coefficients, you cannot estimate the structural parameters. Or in other words, you can say that if more than one theories are consistent with the same data, the theories are observationally equivalent in the sense that we cannot distinguish them. Say in the first example of unidentified case, what we observe that we cannot distinguish between demand function, supply function and a linear combination of them. So, suppose you have data on demand and supply and then you are fitting a model between demand and price, then you will not be able to say whether you are estimating demand function or supply function or one of their linear combinations. So, in some sense you can say that more than one theories are consistent with the same data, and that is why the theories are observationally equivalent. Demand function, supply function and their linear combination are observationally equivalent, and we cannot distinguish between them. In exactly identified case, the estimation of parameters is possible in this case. The relationship between the reduced form coefficients and the structural parameters is 1:1. So, there is a 1:1 relationship between reduced form coefficients and the structural parameters, and you can solve the structural parameters in terms of the reduced form coefficients, and the solutions are unique also. So, if the ordinary least square estimator of reduced form coefficients are available, if you estimate the reduced form coefficients using the least square procedure, then these estimates lead to unique estimates of structural coefficients. So, this is the case of exact identification. There is a 1:1 correspondence between structural parameters and reduced form coefficients, and this has an advantage. You get unique solutions for structural parameters in terms of reduced form coefficients, and then if you estimate the reduced form coefficients, you get unique estimates for the structural parameters. Then we consider the case of over identification. In the case of over identification, the estimation of parameters in this case is possible. Still you can estimate the parameters. The ordinary least square estimator of reduced form coefficients lead to multiple estimates of structural coefficients. So, if you adopt the procedure that first you estimate the reduced form coefficients and then you try to obtain the estimates of original structural parameters by solving the relationships between structural parameters and reduced form coefficients, then it leads to multiple estimates of structural coefficients. So, definitely this procedure may not work and you require some alternative procedure for estimating the structural coefficients, but still in over identification case you can estimate the original structural form coefficients. It is possible. Again we notice that the identification problem is not the sampling problem. So, it is not like that you increase the sample size, then you can resolve the identification problem. It is not a sampling problem. The problem is with the structure of the model, with the formulation of the model. So, while formulating the model, you have to be careful that each and every equation is identifiable. So, at least no equation remains unidentified, otherwise you cannot estimate that particular equation. If it is over identified, then it is not a problem. Still you have procedures to obtain unique estimates of parameters. But if a particular equation is unidentified, then you do not have any option. You cannot estimate the parameters of that particular equation. So, this is not the sampling problem, this is the problem of proper model formulation or proper formulation of different equations of the model. Again, in the reduced form y t equal to pi x t plus v t, pi is equal to minus b inverse gamma. So, we can consistently estimate pi using ordinary least square procedure. Now, if b is known, we can simply write gamma equal to minus b pi. So, if b is known, then there is no problem. You can simply estimate gamma. You have the estimates of pi's, the reduced form coefficients, and then you can easily find the estimates of gamma using this relation. Then actually our problem lies, or our problem actually come to the estimation of b. And this makes sense also, because if b is known, then suppose in this model we write b y t equal to say z t, then you get z t plus gamma x t equal to u t, or z t equal to minus gamma x t plus u t. So, if b is known, then you can obtain z t, and then using this equation you can estimate gamma directly, because these x t's are uncorrelated with the disturbance term u t. So, you can directly apply OLS to estimate gamma here. So, we can put the identification problem in this form. Say we can observe the reduced form and must be able to deduce the structural form from the reduced form. So, for a particular equation, if you are able to deduce the structural form, means if you are able to deduce the structural form coefficients using the reduced form coefficients, all the reduced form coefficients, then you say that that particular equation is identifiable. Now, if more than one structural forms lead to the same reduced form and we are not sure which structure we are estimating, then we cannot estimate the structure, and in that case we say that the equation is unidentified, it is not identifiable, because on the basis of estimates of reduced form coefficients, you are not sure which structural form you are estimating. or which structural form has led to this particular reduced form. So, that is why that particular equation is unidentified. So, in this lecture we have discussed the general structural form of the simultaneous equations model, and then we have also discussed the reduced form of the model. And then what are the issues related with the identification problem? We have discussed with the help of an example. In fact, if on the basis of reduced form parameters, we are able to find the solutions for structural parameters of a equation, then that particular equation is said to be identifiable. If we are not able to find the solutions, then that equation is said to be unidentified. And even if the equation is identified, sometimes you may have more than one solutions. So, in that case, that particular equation is over identified. In unidentified case, it means on the basis of reduced form, you are not able to say with surety that which structural form has generated this particular reduced form. You may have more than one structural equations leading to the same reduced form. So, that is why the equation is unidentified. In the next lecture, we will discuss the rank and order conditions for the identification of the simultaneous equations model. So, I am going to stop here. Thank you.
Hello and welcome to this piece of literary snippet. We usually know William Shakespeare as the most revered figure in the history of English literature. But we often tend to forget that he has also been one of the most hated figures in literature. And here I am not talking only about those boys and girls who have to memorize long sections from Macbeth or King Lear or Julius Caesar before they can go and sit for their school or college exams. But I am also talking about people who are themselves quite famous authors. Tolstoy, for instance, considered the writings of Shakespeare to be, and I quote, crude, immoral, vulgar, and senseless. George Bernard Shaw absolutely loathed Shakespeare, as he did Homer. But perhaps no other criticism about Shakespeare is more damaging than the one which says that Shakespeare is a marvelous storyteller, provided someone has told him the story earlier. Now, this piece of criticism is particularly damaging because it is true. None of Shakespeare's plays contain any original story whatsoever. They are all written using pre-existing materials, pre-existing stories. Now, does that diminish the stature of Shakespeare as a dramatist? Well, I'll leave that for you to decide. See you in the next episode of Literary Snippets.